Hello, I am Loretta Donaldson, and this is my poster over the use of T2 mapping to increase tumor conspicuity in fluid-suppressed T2-weighted magnetic resonance images. T2 values represent the time constant for the exponential decay of the transverse magnetization and magnetic resonance images, and these T2 relaxation times are tissue-specific, which allows us to use these values for tissue differentiation. Creating a T2 map can help us identify areas of interest in the image and see any abnormalities. The in vivo data that I was working with was abdominal images that had kidney cysts and lesions, and the fluid-suppressed T2 maps show how these types of abnormalities compare to the surrounding tissue. To obtain the T2 maps, first the images were taken using the detect method to get sets of images that could be processed using MATLAB. Water-only image pairs were taken at a short and long echo time for fluid suppression because areas with a high water content have a longer T2 and will appear in both the short and long images, while areas with a lower water content will appear mainly in the short echo time image, and we can take the difference of these two images to suppress the fluid signal in the final image. In MATLAB, a dark fat algorithm was also used to compare a water-only image to a fat-only image and suppress any fat signal that leaked into the water image. These techniques help to make the fluid-suppressed water image more clear for the creation of the T2 map. I had data for 3 subjects, and my first objective was to look at the fluid-suppressed T2 map for subject 1 and note any interesting patterns in the T2 map. Figure 1 shows my results for this, and one notable pattern in the T2 map is the contrast difference between the medulla and the cortex of the kidney. Looking at the water-only image, it is difficult to differentiate between these sections, but it is very clear in the fluid-suppressed T2 map. My next subject had a cyst on the kidney, and I wanted to see how that tissue abnormality appeared in the fluid-suppressed T2 map, as well as get more information on the distribution of T2 values, and these results were shown by figure 2. The histogram is noteworthy because it tells us that a lot of the T2 values in the map congregate approximately near 100 milliseconds, with the overall range of T2 values going from about 50 to 220 milliseconds. Looking at the T2 map for this subject, the cyst appears as a dark blue spot and can be seen as a bright spot on the dark fat image. Fluid-filled cysts have a high water content, so they would appear bright in both the long and short echo time water-only images, as was discussed earlier, so the fluid suppression algorithm would take the cyst out of the image, and that is why we see a dark blue spot for the cyst in the fluid-suppressed T2 map. The third subject I had a lesion on the kidney, and looking at the dark fat image, this tissue abnormality can be seen because the shape of the kidney is different than normal, and the image contrast makes it somewhat differentiable, but the fluid-suppressed T2 map makes it much easier to see exactly where that lesion is on the kidney. We can also see that the lesion is not visible in the long echo time image, meaning this was not a fluid-filled abnormality like the cyst. Also, the lesion has a shorter T2 value than the rest of the kidney, as shown by its light blue color compared to the red and yellow of the kidney. The benefits of T2 mapping are that it provides us with more information and can help to visualize tissue abnormalities. Usually, T2 maps are obtained by long scanning sequences, so that enough echoes are obtained to create an exponential curve fit. The method using detect images needs only 2 echoes, which means that possibly any scanner taking multiple echoes would be capable of creating a T2 map estimate that can give more information to clinicians. Some possible obstacles related to MR images are artifacts caused by patient movement or metal implants, and there are algorithms that exist to try and suppress these issues, but since T2 maps are created from MRI, any significant signal discrepancies would also appear in the T2 map. Future steps to take in this area of research would be to compare T2 values in the T2 maps to already known T2 values from literature and see how they match up or if there are any common discrepancies. If you'd like to contact me, my university email is lmd160130@utdallas.edu. Thank you for your time.